Hello geometry students. Here's your lesson for section 8.2, trigonometric ratios in 15 minutes or less. Missy McCarthy, Okemos High School math teacher. In this lesson, we'll learn to use these things called sine, cosine, and tangent for an acute angle. Those are trigonometric ratios, and we'll use those ratios to find the side lengths in real-world problems in right triangles. So we're going to get into a little bit of trigonometry, and trigonometry is my favorite. It is nothing more than studying the relationship between sides and angles in a triangle. We're going to focus on right triangle trigonometry, but it can be extended to all triangles. So that's what we're going to be looking at with trigonometry. Now there are three main trigonometric ratios in a right triangle. Sine, that's how the first one is pronounced, usually abbreviated by the first three letters, S-I-N. Cosine is the second, abbreviated C-O-S, and tangent is the last, abbreviated by T-A-N. Now, what are these trigonometric ratios in a right triangle? Well, if we're looking at sine, the sine of an angle is the ratio between the side opposite the angle and the hypotenuse of the right triangle. So in this particular triangle, we're focused on angle A, and sine would be opposite angle A, so the sine of angle A, the sine of angle A would be the side opposite angle A over the hypotenuse of the right triangle. The side opposite angle A is A, and the hypotenuse is C. So that ratio would be the sine of angle A. Cosine is defined by the ratio between the side adjacent to the angle and the hypotenuse of the right triangle. So adjacent means next to. So the adjacent side would be angle B, and then the hypotenuse would be C. So the cosine of angle A would be the adjacent side over the hypotenuse, which is B over C. The tangent of an angle is the ratio between the side opposite the angle and the adjacent side. So again, if we're focusing on angle A, the tangent of angle A would be defined as the side opposite angle A and then the side that's adjacent to angle A. So opposite angle A is small a, and adjacent to angle A is B. So that trigonometric ratio would be the tangent of angle A. So let's see if we can write the trigonometric ratios for each of these. Now we're looking at angle J. We're going to write it as a ratio and as a decimal. So now my focus is shifting to angle J. The sine of angle J would be the side opposite angle J over the hypotenuse. So the side opposite of angle J, if I start here and go across, that would be 60, and the hypotenuse is 61. And then I can also write that in decimal form and say that the sine of angle J is 0.98. Okay. Now the cosine of angle J is defined by the side that is adjacent to J over the hypotenuse. So adjacent to J would be this 11 over the hypotenuse, which is 61. And if we were to find that as a decimal, the trigonometric ratio, the cosine of J, is 0.18. And these should be approximately. And then lastly, the tangent of angle J is defined as the ratio of the opposite side to the adjacent side. So the opposite side is 60, and the adjacent side is 11, which is approximately 5.45 is that ratio. Now, an easy way that a lot of people like to use to remember the trigonometric ratios is something called SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you can use that to remember the trigonometric ratios. We pronounce it as SOHCAHTOA. Okay, we can also find trigonometric ratios of special right triangles. So remember your 30, 60, 90 and your 45, 45, 90 triangle? They're coming back and you will see them again and again. So this says use the special right triangle to find the cosine of 30 degrees. Now we actually have an angle here, and that angle is 30 degrees. Now remember from SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So our focus right now is the cosine. So we find our 30-degree angle, which is here, and we need to go adjacent to the 30-degree angle. This is adjacent, which is s square roots of 3, and then the hypotenuse. Here's our hypotenuse, which is 2s. So if we cancel the s's, s cancels with s, the cosine of 30 degrees, that ratio of the the adjacent to the hypotenuse is always going to be the square root of 3 over 2. Okay, you can also use a calculator to find trigonometric ratios of angles. So on the previous slide, we did the cosine of 30 degrees. And we got that that value was the square root of 3 over 2. So now we're going to look at how you can use a calculator to do that. On your calculator, you would make sure it's in what we call degree mode, because we're doing 30 degrees. Yours will probably already be in degree mode. Then you would find the cosine button. You should see sine, cosine, and tangent, and you would type in cosine 30. You don't have to put the degree mark. Just type in cosine 30. So I'm typing that in right now. Cosine 30, close my parenthesis, and I am pressing enter. Now when I press enter, it gives me approximately 0.866 as my answer. But then when I go to my calculator and I type the square root of 3 divided by 2, that's also approximately 0.866. So practice finding these on your calculator. What if I ask you to find the tangent of 52 degrees? So go to your calculator, type in tangent of 52, and see what you get. When I type in tangent of 52 degrees, I get approximately 1.27. Approximately 1.27. Okay. All right, so we're going to have to use our calculator to calculate some of these. We got to find the length of BC in this triangle using our trigonometric functions. We know the angle B is 15 degrees. We know we have the side that is opposite of angle B. This is opposite of angle B, so that's one thing that we have. And we're looking for BC, so BC is right here, and that is adjacent. So I think about what trigonometric function do I have that associates the opposite and the adjacent, and that would be tangent. So it would be the tangent of angle B is the opposite over the adjacent. And I know angle B is 15, so the tangent of 15 degrees is the opposite, which is 10.2, over the adjacent, which is BC. That's what we don't know. Now, if you multiply both sides by BC, you get BC times the tangent of 15 degrees is equal to 10.2. And then divide both sides by the tangent of 15 degrees, you get BC is equal to 10.2 divided by the tangent of 15 degrees. Now remember, our calculator will do the tangent of 15. So you have to do 10.6 divided by the tangent of 15 degrees. I'm typing that all in at once, and I get 38.07. 38.07 would be the length of BC. Here's another one to try. This time we're going to be looking for the length of QR. So if we're looking at the triangle, we have to assess what we have. We have P, which is a 60 to 63 degree angle. We're looking for QR, which is opposite of P. And we have 12.9, which is the hypotenuse. So what trig function associates the opposite with the hypotenuse? And that would be sine. So the sine of angle P is the opposite over the hypotenuse. That would be the sine of 63 degrees. The opposite of 63 degrees is what we don't know. That's QR. And the hypotenuse is 12.9. So if I multiply both sides by 12.9, I get 12.9 times the sine of 63 is equal to QR. And now I'm just going to type that into the calculator. 12.9 times the sine of 63, and that gives us 11.49. So QR is approximately 11.49. Now we're going to use what we know about trig to solve this application problem. It's talking about a railway that is relatively steep. It's the world's steepest, and it rises at an angle of 25.6 degrees with the horizon. So starting here, starts to rise at an angle with the horizon of 25.6 degrees. And it rises about 0.9 kilometers. Okay? So the rise is 0.9 kilometers. That's how far it goes up in a vertical distance. So it's saying to the nearest hundredth of a kilometer, can we find how long this section of track is? So we're looking for this distance right here. How long is that section of track? Oh, I'm sorry. We're not looking for that. Where is the track? The track is right here. How long is this section of track where it rises 0.9 kilometers at this angle? So if we're assessing what we have so we know which trig function to use, the 0.9 is opposite of the 25.6, and D is the hypotenuse. So opposite and hypotenuse, that would be sine. So we would say the sine of 25.6 degrees is equal to 0.9, which is opposite, and D, which is the hypotenuse. Multiply both sides by D, and we get D is equal to, oops, it's not equal. It's D times the sine of 25.6 degrees equals 0.9. Divide both sides by the sine of 25.6. D is equal to 0.9 divided by the sine of 25.6 degrees. Remember, that's just a number. I'm doing it on my calculator now. 0.9 divided by the sine of 25.6. And I get that that stretch of track is approximately it says how long to the nearest hundredth of a kilometer. So 2.08 kilometers. Approximately 2.08 kilometers long.